The semiconductor industry is currently witnessing an unprecedented surge in fab construction and investment on a global scale. This surge is primarily fueled by the escalating demand for advanced technology and the necessity for a robust supply chain. With over 70 new fabs under construction worldwide and substantial investments, such as the $450 billion in the US alone, thanks to initiatives like the CHIPS Act, the industry is experiencing a significant transformation. These facilities are crucial for producing next-generation chips for AI, EVs, and other cutting-edge applications. However, this rapid expansion has its challenges. Let us break it down. The race for semiconductor self-sufficiency is a global one, with countries across the globe making strategic investments. In the US, new projects by industry giants like Intel, TSMC, and Samsung are creating a wave of economic growth and job creation, positioning the country as a critical player in the industry. Europe, Japan, and South Korea made strategic investments following the US lead. The ultimate goal is to reduce dependency on a few key regions and ensure stable chip access. This surge is not just about quantity and advancing technology. Many new fabs will focus on nodes below 10 nanometers, which is critical for high-performance computing, AI, and EVs. However, mature nodes for consumer and industrial applications are also in high demand. These fabs are crucial for innovations in various fields, from autonomous driving to smart cities, creating a technological backbone for the future. Despite the optimism, significant challenges are ahead. The semiconductor industry is known for its cyclic nature, periods of high demand followed by slowdowns. For these new fabs to be profitable, utilization rates must be consistently high. If demand does not keep up with this massive capacity increase, overcapacity could lead to financial strain. Another critical issue is the balance of the semiconductor supply chain. While fabs are being built rapidly, the supporting infrastructure, assembly, testing, and packaging may not scale as quickly. The back-end processes are currently dominated by a few key players, which could create bottlenecks if demand surges beyond pandemic levels. The result? Longer cycle times and potential delays in bringing products to market. The FAB Surge underscores the critical importance of a skilled workforce in the semiconductor industry. Advanced manufacturing, particularly in the semiconductor sector, demands highly trained engineers and technicians. However, there's a growing concern that there may not be enough talent to operate these facilities efficiently. To address this, countries need to make significant investments in education and training to meet the industry's demand for skilled workers. While traditional semiconductor powerhouses are leading the surge, countries like India see a unique opportunity to enter the semiconductor ecosystem. India could significantly balance the global supply chain by focusing on back-end services and leveraging a solid talent pool. For the industry to truly benefit, there must be a strategic alignment between fab capacity, supply chain infrastructure, and global market demand. Investments in advanced nodes must complement those in assembly, testing, and packaging. Moreover, governments and industry players need to collaborate to ensure the sustainability of these investments. In conclusion, the semiconductor fab surge is a monumental step toward meeting future technological demands and ensuring supply chain resilience. However, it must be managed carefully to avoid pitfalls like overcapacity and supply chain imbalances. The success of this surge will depend on a coordinated effort across the entire ecosystem: fabs, back-end processes, talent development, and market alignment.